Welcome friends to my YouTube channel. Now on my last lecture I have told about the light beam and depression due to a light cantilever or a light beam. Okay, that is if this is a beam, okay, this is x equal to 0 end and this is x equal to L end. So at the free end there is a load, say W. Okay, and this is the bending, say we take a point, say pxy. Okay, so this is y, this is x, and this length is L minus x. Okay, so we have calculated the depression at point P as this: w by y ak square into Lx square by 2 minus x cube by 6. That is the depression at point B. And we obtain the depression at the free end, say it is y dash, by putting x equal to L. That means w by y ak square, this is L cube by 2 minus L cube by 6. Okay, so w L cube by 3y ak square. Now remember, I told you that if the beam is of rectangular cross section, say this is a rectangular beam, okay, say this is a rectangular beam, its length is L, breadth is B and width is D. So this is the area of cross section. Okay, so for a rectangular beam, what happens? For a rectangular beam of breadth B and width D, A is BD and K square, this is D square by 12. That we know. Okay, now if we substitute these values, then what would be the depression corresponds to a rectangular beam, that is say y dash, this is simply WL cube by 3y, A is BD and this is D square by 12, that means 12 by D square. So 4WL cube by y BD cube. Okay, so this is the depression for a rectangular beam. Okay, at first we take the general expression and then considering the beam to be a rectangular one, we find this. Now one thing remember that there is a load attached at the free end. Okay, and consequently each and every point in the beam will experience a shearing stress, no doubt. Okay, say this is the weight. Okay, okay, so this is shearing strength theta. Okay, say this is L. Okay, and this is say y dash. Okay, now due to the load W, we know that each point in the beam experiences a shearing stress. So if we consider a rectangular beam, that is for a rectangular beam, each point experiences a shearing stress of magnitude, what, force per unit area. Here force is the weight, and for a rectangular beam the area of cross section is this. So this is the shearing stress. So what would be the shearing strain? The corresponding shearing strain theta, this is simply y double dash by L. Okay, this is simply y double dash by L. So what will be my rigidity modulus? Shearing stress by shearing strain, that means WL by y double dash BD. So from which we can write y double dash this equals to WL by eta B. Okay, so we get this. Now if we do y dash by y double dash, y dash by y double dash, this is simply 4WL cube by YBD cube divided by this. This means eta BD by WL. Okay, so 4 into eta by y, this is simply L by D whole square. Okay, now for a rectangular beam, we all know the length is very much greater than the depth. So from this expression we can easily write y dash, this is very much greater than y double dash. So y double dash, that is the depression due to shear, okay, is very small. So for this reason we don't take into consideration, okay, the depression due to shear is very small. Okay, so for this reason we don't count the effect of shear. Okay, obviously for a rectangular beam, okay, that means the effect of shear is neglected. Effect of shear is neglected. Okay, so dear guys, today we discussed about the effect of shear on the cantilever light beam. Now in my next lecture I shall going to discuss few other issues related to cantilever, and video link will be given in the description box. If you like this video, then kindly subscribe my channel. Okay, thank you.